Our first story is Cheshire 200 million years ago, the rocks beneath our feet. So, how come this sandstone was made? What happened? What about the formation of salt in Cheshire and the local coal? Those are possibilities for this story. The local rocks have really got a story to tell. They're Triassic rocks from between about 250 and 200 million years ago. Perhaps easier to say than to imagine, when the world was very, very different. The Triassic period was way before people. It spans the rise of the dinosaurs and of the earliest mammals. To give a perspective, you might ask the class how long 200 million seconds is, and the answer to that is over 6 years. So between 250 and 200 million years ago is breathtaking. 250 million years ago, there were no British Isles, there was no Europe, just one supercontinent. Geologists refer to that as Pangaea, and since then there's been continental drift as shown in this animation. It's maybe useful to get a globe and look at it with a class and think about how the continents of South Africa and South America jigsaw fit together. This, alongside the similarity of the fossils found in the two continents, led a scientist called Alfred Wegener, he was actually a polar scientist, to propose in 1912 that they might once have been fitted together. And lots more evidence has come to light apart from the jigsaw fit, so that this theory is now believed. Continental drift and a changing climate. The climate of where our rocks were formed and where Halton is now was near the equator, and it was very hot and very dry. Our rock formed over many millions of years as desert sands were windblown into dunes and came to build up under the pressure of more sand on top. Layers were formed in the sandstone over time as the seasons changed. A good family activity might be to look at sandstone and see who can spot the really clear layers. And a class activity might be to look at sandstone with a hand lens and see the grains, or with the macro lens that schools taking part in the project will get with their kits. The elements in sandstone are silicon and oxygen, which make silica or silicon dioxide. The sandstone here is red because there's some iron compounds in there. Rust is red, and that's iron oxide. That's the silicon structure, the crystal structure of quartz or silicon dioxide, the stuff of which sand and which glass is made. SiO2. Now, this is a photograph that I took with a smartphone and a macro lens over the top of the sandstone in my gatepost. You can see the sand grains. Those have been stuck together for somewhere between 250 and 200 million years, and I can rub them apart with my thumb, just the odd one. They've been stuck together for all that time, which is a little bit awesome. The black deposits at the bottom have got a more recent history. They're the industrial soot of the Northwest that's been there through the Industrial Revolution of the last 100 years. Now, during the Triassic period, there were lakes. Remember, we were landlocked, we were near the equator. Rivers flowed into those lakes and they carried minerals from the rocks with them, and the water evaporated. The lakes didn't flow out to the sea. Minerals from the rocks got washed in, couldn't leave. And so, just like with the Dead Sea and salt lakes in the United States and South America, the lakes dried up and left the salt behind. And that's an image of a salt lake in Bolivia. And it's like Cheshire 200 million years ago. The elements in the salt are sodium and chlorine, because salt, common salt, is sodium chloride. And a possible class activity might be to grow some crystals of sodium chloride. Children could do this at home in a jam jar. You could do it in school. We've provided some potassium ferrocyanide and a risk assessment for it. It doesn't seem to pose problems, but do have a good look at the risk assessment. Do make a risk assessment for your context. You can pour some salt solution, add a couple of drops of potassium ferrocyanide, leave the salt, the brine, for a few days, and you should get some crystals forming. And they branch. The branching's being caused by that impurity that you've added. You can have a look with a lens. It might be really good to take a look under the macro lens, take some photographs. Another possible activity for children is to create layers of sediment in a fish tank or other container. There's ideas on Pinterest for fossil formation that they could do maybe at home. Now, coal appears in many of our stories. It's relevant here because coal formation, again, back way time ago, before sandstone, it was from about 290 to 360 million years ago. So the Carboniferous or coal forming period lasted about 70 million years. That 70 million years of coal formation contrasts hugely with about 200 years of intensive coal use by people, and mostly the last 50. So plants over that 70 million years were taking carbon dioxide out of the atmosphere and making carbon appear as coal. We have returned that carbon to the atmosphere as carbon dioxide very quickly, and that links with climate change. So that is something that we really need to think about, and something for the generation of children who are students in schools now that they're going to have to face the consequences of. Those plants grew under tropical conditions in the Carboniferous period. They were giant horsetail plants before there were trees of the type we know now. They were like trees, but they were different. And this drawing's from 1902, from an artist imagining the hot and steamy forest with the ancient plants. The element in coal is carbon, which is the basis of all living molecules in living things. Now, excuse my slightly fuzzy photo, but a potential activity here is to contrast the present rather favourably with a recent industrial past. That's a view of Halton, as you can probably tell, and houses and trees, but it's quite a green landscape. The Woodland Trust is really active in Halton. There's a lot of woods. Halton occupies about 4% of the land area of Cheshire, but it's got a much higher proportion of the land in the Woodland Trust's custody within it. And that is making a huge difference. And I think that you'll see how much the land has changed since the more industrial past. Okay, there's more houses, but look how the tree cover has changed. So an activity for families might be to compare locations that feature in the Halton Heritage photographic website, where you can find images from the industrial past, and compare that with the present, and think about what more can be done, and what can be done to reforest the world generally.